Hi there, welcome to Math It Is, and in this video I am going to represent irrational numbers on number line. For those of you who have seen my previous video, I had used the method of spiral, the spiral method of representing irrational numbers, which is mostly used when the number under the square root sign is a whole number. But this particular method, what I am going to explain to you today, can be used for any type of irrational number. Okay, so let us start first. What the first step is to take a number, a line segment which measures exactly 5.6 units. Okay, so it could be something like this. So let this measure 5.6 units. Okay, whatever is given there. Then this is my first step. Let me name it as, though I don't have to name this, but I'll explain to you later why I am naming it. Okay, whatever number is taken, to that you will add 1 unit. Now let me take a different color to explain that. So approximately from here I will add 1 unit. Okay, so this part is 1 unit. This is the second step. Then what you will do is construct the perpendicular bisector of the line segment AC using your compass. Okay, so for that, if you remember, we take an arc which measures approximately more than half of AC, and with A as center we try to draw arc on either side. We keep the radius same, and with C as center we try to draw arc with the same radius, so that when I try to join the 2 points, I'll get my midpoint. Okay, let me name my midpoint as M. Okay, let me name it as M. Okay, M. So this is my midpoint. Then what we do is we try to take this midpoint as the center and radius MC. Okay, now I can take MC or I can take MA because M is the center. So we try to take M as the center and radius MC and draw a semicircle. So the semicircle will look something like this. Okay, it's not exactly same, but if you use a compass it will come properly. And then what you will do is at B, which was the end of the 5.6 unit segment, at B you will construct a perpendicular, so which will meet your semicircle at some point D. Okay, now this part BD is nothing but your required 5.6. Okay, so how do you show that on the number line? You can always take B as your center. So now B will correspond to your actual origin. Okay, so this will correspond to 0. You can extend your number line some here, and then you will measure OD or BD as the radius and try to draw a arc. Okay, so that wherever it is meeting, okay, your OE part will be equal to root 5.6. Okay, and the explanation for this I will do using a general number Rootx. Here also we use the concept of Pythagoras theorem only, but it is slightly more complicated than in the spiral method, but of course not difficult. And I'll show the explanation using Rootx. So you can use this method for any type of irrational number. So let me move on to that particular figure. Now for the proof, I have taken in general the number Rootx. Okay, so I have tried to follow the same steps. First draw x units, extend it by 1 unit, construct the perpendicular bisector. M is the midpoint with M as center. Draw a semicircle. And then at B, which is the end of X, draw the perpendicular, so that MD is the required root x. And then you can take MD as your radius and drop an arc to meet the number line, so that the end of x units what you had taken actually becomes the origin, and starting from the origin this length becomes your root x. Now the proof follows like this. As you can see, AB is equal to x, BC is 1 unit, therefore AC becomes x plus 1. And since M is the midpoint, MC becomes x plus 1 over 2. Okay. Now once you have dropped the perpendicular, since D is lying on the same semicircle, so MD will also be equal to x plus 1 by 2. Then comes your MB. MB, if you can see, is just 1 unit less than the radius. So MB is x plus 1 by 2 minus 1. When you simplify it, you get it as x minus 1 over 2. Then the next step is using Pythagoras theorem. We try to find BD. Now if you can see, BD is nothing but MD square minus MB square. So we just substitute the values and we get it like this. And then you do basic steps. X plus 1 square, I have tried to expand this, minus, so all the signs inside the bracket will change. So I get this, x square and x square gets cancelled, 1 and 1 get cancelled, and I am left only with 4x over 4. How am I getting 4? Because 2 square, 2 square. Same like terms, so we have the common denominator 4. So that 4 and 4 also get cancelled, and what you get is root x. Okay. So this is the proof, just for your understanding, because if you understand why we are using a particular method, then it becomes easier for us to do the same thing. Okay. Though you may not be asked to prove this every time. This is just for your understanding. So before I end the video, let me recall all the steps. These are the steps. This is for joining for any root x. Okay, what is step 1? Draw x units. It could be x centimeter, it could be x inches, anything that you want. Okay, you have to draw x units line segment. Step 2 is extend the line segment by 1 unit. Okay, so whatever units you are using here, it should be the same unit. Step 3, locate the midpoint of the new line segment. So locating is by actual construction if you are actually representing the length of root x. Step 4 is draw the semicircle with the midpoint as center. Step 5, you will draw the perpendicular at the end of x units, which is the B part, okay, to meet the semicircle. And step 6, the perpendicular, the length of the perpendicular is nothing but root x. So you can take that as your radius and drop it again on your required number line. Okay, so that when you take the end of the line segment B to correspond to your origin, then from there whatever unit you will get here will be the required answer. Hope you liked my video, and if you want me to take up any particular topic, please write in the comment section. See you in the next video.